Hey guys, welcome back to my YouTube channel. So we have seen so much theory for the long lectures. So now let's brush up our testings. So how you guys understand the semiconductor physics when we coming into application level. So here is one of the question that is asked in gate I think 2011. So here is the question that for a p-type semiconductor following data is given like the doping profile Na, it is in p-type so acceptor atom. So intrinsic energy level as well as Kt. So Kt as we know that is 26 milli. So it is in energy level so that is given as EV. So effective density of state NV also they are given. So now they are asking us to find the position of Fermi level EFP with respect to valence band. So EFP minus EV. So that is what they are asking. So we already know this formula. So KT which will be ln NV divided by NA. If you guys even forgotten, you can calculate it or you can also remember from my shortcuts that I have already said you. So the answer is that. So we have to apply KT which is equal to 0.026 so ln NV which is equal to 10 power 20 then 10 power 4. Okay. So if we cancel out then it will become it is 10 power 16 sorry. So 10 power 16. If we cancel it will become 10 power 4. So if we take into account 0.026 into ln of 10 power 4 EV. So I'm giving this to you. So the answer is that EFP minus EV which will be equal to 0.026 into ln of 10 to the power 4. So you guys can even use calculator directly answer it. So I hope it is understood for you. So here there is no difference, no difficulties I think. So the every data is given, so we are directly substituting it. So here it's coming one of the very important question. I will like this kind of questions whenever we are studying this in very conceptual way. So this is one of the questions that is asked I think twice in the gate. I think not the same, but they are repeated some same logic with some differences. So let's get into this core. So please pause the video and try to answer it. If you guys able to answer these kind of good questions, then you guys can you guys can appreciate yourself that you guys can crack any kind of question in semiconductor physics. So the energy band diagram and the electron density profile n of x and energy band diagram both are given below. So assume that n of x they are given some n of x as a graph curve dependency also. This curve the doping profile they are given 10 power 15 e power q alpha x divided by kt with alpha some constant value and x is in centimeter. So kt by q is equal to 26 millivolt. Some diffusion that dn that is that diffusion constant also they are given. So d by mu which is equal to kt by q. We already know that is Einstein's equality. So that also they are given. And then this equation will relate the mobility as well as the diffusion factor. Okay. So the electron current density at x is equal to 0. That is what the question they are asking. So we could clearly see that from the question they are asking the Jnet as it is an n type as they are suggested. So we could clearly see the Jn drift plus Jn diffusion. So these two things we have to find because they haven't mentioned that it is uniformly doped or anything. So, but from the graph we can clearly say that there will be some kind of drift plus diffusion. So we know that this formula will be equal to, so let me write it here itself. So it will be equal to nq mu n e plus q dn by dx. So what are the term missing here is that mu n is missing, e is missing. The rest of the term we have n we have, dn by dx we can differentiate it, and also everything we have. Okay. So for your understanding, let's me write what are the given data. So n of x which is given as 10 power 15 e power q alpha x divided by kt. So this is given. Alpha which is equal to 0.1 also given. Dn which is equal to 36, that is also given. Okay. So we have to find out one thing is the E. So first of all, let's find out E. So from this graph, we can clearly see there is a slope. From this slope, we can calculate the E. So we know that the electric field which will be directly proportional to which is equal to 1 by q dEc by dV dx. So this one from the last class we have seen. So last class you guys may confuse why we are going to this much formulas and this much theory. So in GATE or any kind of examinations, we need those kind of data here. So we need to remember this one in order to find that. So E dash, the electric field which will be equal to 1 by q EC by Ex. So this is nothing but a slope. So they have already given the slope value which is minus 0.1. Okay, so we can directly substitute that, which is 0.1. So if we calculate it, then we can clearly divide it. So as we know, this is EV. So I'm giving that this is EV, 0.1 EV. So this E, this Q can be cancelled. So if that is cancelled, then the answer will be minus 0.1 V divided by M. So this is the unit of electrical field. So we have find out the E. Now we have to find out the mu. So for that we have a relation, density inequality. D by mu, which is equal to Vt or Kt, anything is fine. So from that we can calculate mu, which is equal to dN by Vt. Okay, so which is equal to 36 divided by 0.026. So we have got all the data. So let's substitute everything in the equation. So the J net which is equal to 10 power 15 e power q, let's keep it as it is alpha kt, and then we can substitute it. So q, mu n we know, right? So we can directly substitute that also. So mu n, which is equal to 36 by kt, 36 divided by 0.026 into my electric field we know, that is minus 0.1. Okay, then plus. So then we q, let's keep it q as it is, and then dn we know, that is 36. So dn by dx. So we need to differentiate this. So let me write the another one term. So dn by dx, which is equal to 10 power 15 e power q alpha x divided by kt. So the e power differentiation term. So this term we will be writing the same. It is the x will be differentiated. So q alpha divided by kt. Okay. So let me write that one directly here. So into 10 power 15. Let me bring the constant before. So q alpha, which is equal to q I am keeping as it is, but I am applying the alpha. Q we know, that is already there. So q by kt, so which will become 0.1 divided by 0.026. So I am writing over here that into 0.1 divided by 0.026 into 10 to the power 15 e power q alpha x divided by kt. So here you can clearly see that there is some kind of constant, like you see there is some common terms that we can group together. So let's see what are the common terms that they are there. So I hope this is understood for you guys. So this section is written from here. So this kt, the kt by q, we know the formula, the kt by q, which is also equal to 0.026. So that thing only I written here. So alpha, which is equal to 0.1 kt by q. So for your understanding, I'm writing here. So which is nothing but q alpha divided by kt. So that thing I'm directly grabbing it here. So this constant term I'm writing here. Okay. So what are the terms common here is the this one is constant, q is constant, 36 is also constant. Here you can see, and divided by kt and divided by 0.26 also constant. Q is also already constant, and this term is also already constant. So if we take everything outside, so 10 power 15 e power q alpha x divided by kt, then q is constant, 36 divided by 0.06 is also constant. Okay, I hope all the constants are removed outside. So pending term is minus 0.1, here it is plus 0.1. Okay, so if we can clearly see, that is an equal to 0. So you may wonder that this much huge numericals are resulting us into 0. So we can clearly state that the jn net, which is equal to 0 in this term at x is equal to 0. Okay, so this from here itself we can see that is equal to 0. So we could clearly understand that this value, whatever the value of x it come, the value will be equal to 0. Not only at x is equal to 0, even if it is x is changed, everything will be 0, because x is dependent here only. We haven't substituted x is equal to 0. Before that itself, this came into 0. This is why, because is that we need to understand here they have given the variation, but they haven't informed any kind of thing that there is an external electric field which is happening. This voltage variation, this profile, there is a diffusion profile is happening. The diffusion current, diffusion movement will happen, but without any external electric applied field, external voltage field, there won't be any kind of possible current movement. So that is what we have to resemble here, that without any external supply of voltage or anything, whatever may be the things you can apply, the J-net profile will be always equal to 0. So this is not only for N type, similarly for P type. I hope this question is giving you some quite understanding, like huge numericals will be there, but that is not the intention I am trying to apply here. So here you need to understand, the thing is that some guys may smartly behave it. So there is no external supply voltage given. So from the graph I could clearly see that there is no variation in the Fermi level of the acceptor atom or donor atom. So the J-net profile will be equal to 0. Like that way also we can answer. But that is most of the time it may not result in a good way. So for that we can also cross check with the applying the numericals into the value, because the examination point of view they may vary the numericals, right? So we have to be very careful in that. So I hope it's understood for you guys. So let me re-explain it once again. So we know the n, q, mu n, everything we know, but mu n, e we not know. So from that we have find out the e. So e is nothing but with this formula 1 by q, the slope of the conduction band. So that is from that we have find out the value of e, and then the with the Einstein equation we have calculated the mu n, and we are substituting everything in here. So we know n is dependent on x, so dn by dx value is here. So e power x is e power x only. So if any other term other than that is there, we need to multiply the constant before that. So that we have done there, that is q alpha divided by kt. So kt by q, which is equal to 0.026, so we have inversely written it 1 by 0.06, and there is inverse return. So alpha is equal to 0.1. So if we remove all the common terms like 10 power 15 e power qt is e power, that term is common, then q is that is common, so 36 divided by 0.06 also common. But the difference term, the remaining term we have right here, that is minus 0.1, and here it is plus 0.1. So if it will be cancelling to 0, so we will be getting J net which is equal to 0. This not only for 0, it will be for all the value, because there is no external electric field that is applied. So that is what the understanding that we have to remember. I hope this is very clear for you guys. So if you guys have any doubt, please ping in the comment section. If you guys are able to understand it, then I am very much appreciating you that you are on a right track. So like, share and subscribe channel, and stay tuned for all the these kind of questions. I hope from the semiconductor point of view, this much understanding is fine. So from the next class, I will be starting with the interaction of semiconductor physics, semiconductor devices with some light. So based upon the light in the incident, how the semiconductor electron generation, recombination will happen, and some kind of other theorems that will be touching you from next classes. I hope some background, I think 90% of background in semiconductor physics is done. So some 10% I will took 2 to 3 lectures, and then we can go to PN junction diagram. So okay, stay tuned for the next lecture guys. Thank you so much.